Good afternoon and welcome to a Wild Wednesday. Does it feel like a truly Wild Wednesday today? I saw some eyebrows go up, so either you're incredulous that I would suggest that it's a Wild Wednesday, or it really is. I think it really is. So let's take a look at some of the Delta Math questions that I've just prescribed in 4.5, factoring complex and special trinomials. Special trinomials coming in this video, so we're going to look at how to do special trinomials. These factor trinomials where a is greater than 1, we're going to get questions like this: 3x squared plus 20x plus 25. So first step is to copy out the question. So here we go. I copied out the question. And then next we play X game. Well, first, always check for common factors. Is there any number that's divisible by 3, 20, and 25? Or that all three of those numbers are all divisible by? No. No. Yes, that was right. No, because 3 is prime and 20 is not divisible by 3, so there's not going to be a number. Okay, so I take 3 times 25. Some of you call this the hat method. Put that there, 75. And then down here, 20. Okay, they're all positive. Now I'm looking for numbers that multiply to 75 and add to 20. Okay, what could those be? Let's see. So 75 could be 3 times 25. That doesn't work. 75 could be 15 times 5. That works. 15 and 5. Okay, so when I have these two numbers, what I'm going to do next is I'm going to set this to be a pen that's useful by not making it an arrow. There we go. So this number and this number, I'm going to use that to break this term down, including the x. Okay, so let's do that. We're going to write it as equal to 3x squared, and I'm going to look for one of these is divisible by 3. Oh, that one is 15. Okay, 3x squared plus 15x plus 5x plus 25. Notice I grouped the one that was divisible by 3 next to this 3, and this 5 next to this thing divisible by 5. So that's how I decided to group it. So, Griffin, that kind of answers your question of how to play with these to get them to go a little smoother. And then what I'm going to do is I'm going to factor this, and I'm going to factor this. Careful when you draw these brackets. If this is a negative, you have to flip the sign inside to avoid making a mistake when you put these brackets around, okay? So 3x squared plus 15x. Greatest common factor here, they're both divisible by 3, and they're both divisible by x. So I can factor out 3x multiplied by x plus 5. Okay, that's this term common factored. And then I'm going to add, okay, greatest common factor here, simply 5. It's just 5. 5 multiplied by x to get me this back. 5 times x is 5x. And then 5 times 5 is 25. Now I have the same term. Let me use the highlighter. This is beautiful. The same term here and here. Those can be now factored out of the 3x plus 5. So I'm left with 3x plus 5 as one of my factors of this trinomial. And I'm going to multiply this binomial by the one I factored out, x plus 5. There, that's done. Now let's check it and see if we get this. 3, and we just do FOIL here, okay? 3x times x gives me 3x squared. 3x times 5 gives me 15x. 5 times x gives me 5x. 15x plus 5x gives me 20x. And 5 times 5 gives me 25. Pretty cool, eh? Pretty cool. Pretty cool. Okay, so that's done. Final answer. That's factored. Huh? Oh, you want to see it, eh? You want to just like drink it in, just like it's like you're standing 2 meters away from the Mona Lisa, and you just like the security guard is like, stand back, please. No, I need more time with this. Absolutely beautiful piece of mathematics, he says, full of sarcasm. Brian McLogan's brand is being really clear. Maybe my brand could be being really sarcastic. I should just embrace my true nature, sort of take the mask off and show you. So now we're inputting our answer because we're eager to see if we're right or not. 3x plus 5 multiplied by bracket x plus 5. End bracket. I don't know where this extra bracket came from. There we go. Submit answer. Am I sure? Yes, I want to submit it. Yay! Let's see how they do it. Okay, so they may have a different way. Okay, so they say guess and check. Only factors, where the first term is multiplied by 3x, the last term is multiplied by 25. Yeah, this one actually succumbs very easily to guess and check because 3 is prime and 25, there's really only two ways to multiply to that. 1 times 25 or 5 times 5. So there's only two options for B and D, is 1 times 25 or 5 times 5, and there's only one option for A times C here. That's what I do in my head when I used to do these. I like Brian McLogan's method better because it's something I can rinse, wash, repeat. Okay, so then we get that. Okay, anyway. Okay, so that's this type of question. Now, not back yet. So let's do another one. Let's do one that's from level 3, okay? Different, a little harder one. 2x squared plus 17x plus 8. Okay, so first step is to copy out the question. Okay, we have successfully copied out the question. If I told you that actually gets you marks on the test, you'll start doing it. All right, 2x squared plus 17x plus 8. So I use my x game. I do 2 times 8 gives me 16 and adds to 17. Well, that's easy. That's 1 and 16. Why is this level 3? This is not hard at all. So I'm going to break that down into a 1 and a 16. I could put the 16 with the 2, or I could put the 16 with the 8. What should I do? Let's go 2x squared plus x plus 16x plus 8. Let's do that. Then I factor this bit. The only thing that can come out is x. So I would have x multiplied by 2x plus 1. X divided by x is a 1. So don't forget this 1. That's important. That's a common error to forget this 1. Now 16x plus 8. So this will be plus. I can factor out an 8 here. So this will be plus 8 multiplied by 2x plus 1. Johnny?
Could that 2x in the brackets be outside and we flip it with the x?
Like, put the x in there?
Matter?
No, because then this would be 1/2.
No. I mean, if you take the 2x out and then put the 1x in.
1x in?
Yeah,
but then if I divide all of this by, so if, Johnny, I divide all of this by 2x, then I would be dividing this here plus x by, divide by 2x, and then I would have this plus 1 over 2. And yes, I would have a 2x and this wouldn't be there, but I don't want that. That would be weird to have a 1/2 in here. Don't you agree? Yeah, so I'm not going to do that. So now I'm going to get my eraser out because this, I do have an undo function here. Good. Oh, yeah, so then I get this. Now 2x plus 1 is common to both. So I can say that this is equal to x plus 8 multiplied by 2x plus 1. And that's how I will answer these types of questions. You would expand by FOIL to check your answer, and you will find that it's true. This will give you 16x, this will give you 1x, so that's 17x. X times 2x is 2x squared, and 8 times 1 is indeed 8. So that's how you answer these. All right, so now, oh, that's not what we want. Okay. Oh, Johnny, you were writing that down? Yes, I'll show you later. Okay, if you want to continue that note. So now, take a new note, and this will be called special factoring, factoring special cases. Okay, so let's take a look at how we look for special factoring in these. All right, so these are really cool. There we go. So factor special trinomials. We want to be able to factor polynomials that involve difference of squares or perfect square trinomials, two of the special cases we're going to look at today. Yesterday, when we were doing the magic factors game, and you were able to predict which cards that your partners had been holding when they created their trinomials, did any of you encounter any examples where you didn't have a b value, where you didn't have a middle term, it was just x? I actually remember some of you had exactly this problem. Do you remember that? No one? No one remembers? It was yesterday. Yesterday's a long time ago. I agree. It was a long time ago. Okay. If you're a mosquito. All right. So the way you create these types of things, how will we factor that? All right. So let's take a look. If I want to factor this as a trinomial, I can do it. What's my C value here? Yeah, sure, this one. Y equals x squared minus 16. What's my C value? Yeah, y equals 16. That's right. My A value is 1, so A is 1. X squared minus 16. My C value is 16. What's my B value? Recall that this is the way I draw A in the English language, Mr. Jennings. AX squared plus BX plus C. What's my B value here?
0.
0. Very good. So this has a B value of 0. So what I'm looking for are two numbers that multiply to negative 16 and add to 0. What numbers multiply to negative 16 and add to 0? Almost. That multiplies 64. Sorry? Negative 4 and positive 4. So this factors to y is equal to x plus 4 multiplied by x minus 4. Okay? That's what that will factor to. And if I expand to find what that is, I will have x times x is x squared. X times negative 4 is negative 4x. Oh, where'd that go? Plus 4x, negative 4x plus 4x. Ah, that's how I get a 0. Okay? And then positive 4 times negative 4, negative 16. Okay? Now, we have this parabola written in two different forms. We're going to do this for a couple others, okay? Y equals 4x squared minus 9. Watch this. Y is equal to 4x squared minus 9. Take some time, factor that one. Don't worry, I'll wait. So if we factor it using the brute force type method, it works out this way. But another thing that I can notice is, oh, these are both squares. 4x squared is 2x squared, and 9 is 3 squared. This factors this way. This equals 2x minus 3 multiplied by 2x plus 3. Okay. Notice that the terms look an awful lot similar. They just have a different sign in there on one of the terms. The first term is the same. The second term has an opposite sign. Same thing that we're seeing here. Okay. And so there is example number 2 that we have. Here's another one. Y equals 2x squared minus 8. Let's do this one more. This one is fast. Y equals 2x squared minus 8. Okay, factor out the 2 first. Always common factor. Y equals 2 multiplied by x squared minus 4. Okay, always common factor that out first, if you can. Then x squared minus 4. Well, I want numbers that multiply to minus 4 and add to 0. What two numbers multiply to minus 4 and add to 0?
2 times minus 2.
You got it. So this is 2x plus 2, x minus 2. Okay?
And how'd you get to, why didn't you have to do the x thing and stuff?
Well, I didn't need an x thing there because here we need an x thing because we have multiplies to 4 and adds to negative 9. Okay? Sorry. Here we have an a that's non-1. So this is a complex trinomial. So I need to use this method to decompose this middle 0x. And when I do that, it's plus 6x minus 6x. Notice, this is really awkward. You'll never have to do this after we get to the next page in this slideshow. Okay. So now I want you to think about, we're going to come back to this page and we're going to take a look at this. But what do you notice about the factored form for each of these quadratic relations? This one, and this one here. What do you notice or what do you wonder about this? Huh? Oh, highlighter doesn't work here, right? because computers. What do you notice about this one, and this one, particularly about the factors? Jake? Yeah. Are the numbers different or the same? Well, the numbers are the same in both of the factors, but the signs are flipped. Yeah. So yeah, the numbers are different. -3 is different than 3, but they're opposite sign, but the same absolute value. Yeah, they're very similar. The numerals are the same. These are called difference of squares. Okay. These are quadratic relations that have a difference of squares if you can write it as a squared minus b squared. If there's some square here minus another square, they always factor the same way. They always factor like this. They're always going to factor into y equals a minus b times a plus b. Okay? And so what did we start with here? If I said I'm thinking of a function that's y equals a squared minus b squared, then you would say, well, that's the same thing as y equals a minus b times a plus b. Let's expand this with FOIL and see what we get. So then I will do FOIL on this, a times a. Let me just go up so you can still see that. Yeah. A times a would give me y is equal to a squared. A times positive b, this is plus ab. Negative b times a is minus ab. And negative b times b, that's minus b squared. Then I go ahead and I collect my like terms in the middle, plus ab minus ab. So that's y equals a squared plus ab minus ab is 0 minus b squared. Okay, so that's difference of squares. They always factor this way. Done. No, it's pretty easy. No. Okay, let's do some examples. If I have y is equal to x squared minus 121. First, visualize it. What's this parabola's y-intercept? Way down there at what? Here's the point 0, negative 121. Does this parabola open upwards or downwards? Upwards, because a is positive. Good. So it's going to be symmetrical around the vertex. It's going to go like that and like this. Notice that if it's symmetrical around the y-axis, if I told you that this root was negative a, what would this root be? Yeah, it would be the same number but positive. So these roots are going to be symmetrical. They're going to be flipped signs of each other. Okay, so what's the square root of 121? Is it going to be bigger or smaller than 10? Is it going to be a little bit bigger than 10 or a lot bigger than 10? Well, what is it?
I have it on either 11. Yeah, I was thinking 11.
Wait, I was right?
Yep.
Yep.
Let's go, Fisher.
Just guess.
So this is the parabola y is equal to x plus 11 times x minus 11. Okay? So this root here is the point negative 11. That's negative 11, 0. And this is the point 11, 0. You want to connect to graphs and understand these connected to parabolas. All your differences of squares are going to look like this. They're going to have symmetrical roots. The roots are going to look like this. This x plus 11 gives you this negative 11 root. This x minus 11 gives you this positive 11 root. And what's the slope as this parabola crosses the y-axis? Is this parabola rising or falling when it crosses the y-axis? Trick question. It's doing neither. It's flat at that point. The vertex is the point where if it was rising, if it was falling before, now it's going to start rising. If it was rising before, now it's going to start falling. So differences of squares will always do this. they will always have their vertex on the y-axis. That is, by definition, a slope 0 at the y-axis. Slope 0 means my b is 0. My b term here is 0 times x. Okay, so see all these connections. See them all, people, see them all. Okay, so let's keep going. And I'm going to come back to this and draw on all over that one. Okay, factor y is equal to 4x squared minus 49. Who can see it right away now? Anybody? No, because your number sense needs to grow. You need to build your number sense. What's the square root of 49? No. Yeah, you're really just taking shots in the dark. Memorize your squares. You'll know your squares. That's the diagonal that comes down your times tables. Yes, 7. So 7 squared is 49. What's the square root of 4x squared? These are going to factor to something minus 7 times something plus 7. No, it's not 12. 2, yeah. 2x. Watch this. 2x squared is equal to 2x multiplied by 2x. This is equal to 2 times 2 times x is equal to 4x squared. Okay? So, to factor that, all I have to be able to do is see this as something squared minus some other thing squared. And then I have, this is my a minus b, and this is my a plus b. And then I can take apart these differences of squares. Just like that. Okay. All right, so that's this example. This one again would graph and would have a slope of 0 at the y-axis and blah, blah, blah. Okay. Now, one more thing about differences of squares. Difference of squares, I can imagine squares visually also. Okay, so I'm going to zoom in here, give myself lots of room to draw a square that is, and I'll use different color here. I'll get very crafty, and I'm going to draw a square that's x by x, okay? And I can draw straight lines by holding down this button. Watch me struggle with the technology, everybody. No, it doesn't work here. To draw a straight line, do I hold this one? No. Oh, right, it's this here. This does it. No. Shoot, that's not a straight line. Okay, and I don't even have an undo function in here either. No, I don't have it on. Just like this is right on a PDF, so I don't have all these fancy things. I'm gonna do a less crafty. Oh, I can do this. I'm getting really low tech here. Okay, not bad, eh? I just have no idea where to put the ruler. This is ridiculous. This is now me playing. Okay, this is not right. I should not do this in front of students. They will put this on YouTube and make fun of me, or I'll put this on YouTube and make fun of myself. Okay, for frick's sakes. Okay, so, and then I can bring this one across here. Okay, this is x long. All right, this is x by x. So this has area x squared. We can all agree? Now I'm going to cut a piece out of this. I'm going to cut a piece out of this that's going to be 11 big. This is 11 long. This is 11 long. It's a square, and it has area 121. Okay? So this is, I've just written x squared minus 121. That's this area left over. You follow?
Yeah.
You follow me. Okay, cool. All right, I'm just going to erase this because I want this area to work in. Pretty cool, eh? I'm going to do this. Okay, keep going. So now what I'm going to do is I'm going to get out my scissors, and I'm going to snip off this little bit here, okay? And I'm going to take this bit. It has a side length here, 11. And from here to here, what's its length? X minus, well, I cut out a piece that was 11 long there. This used to be a x long, now it's x minus 11 long. This side length here, okay? Now I'm going to take this side length, I cut it out, and I'm going to attach it up here. This is also x minus 11 long because this was a square that I cut out. Okay, so it will fit nicely right there, just perfectly. Okay, and this is 11 long up here, and this is x minus 11 long, and this is x plus 11 on this side. Now we have a rectangle. Its area is x plus 11 multiplied by x minus 11. Y equals x squared minus 121 equals x plus 11 multiplied by x minus 11. Okay.
Oh, that makes sense.
That makes sense? You can see it now?
That's really.
I cut this 11 by 11 square out of the x squared. I move this rectangle, which is 11 by x minus 11. I plant it up there. This side length is x plus 11. This side length is x minus 11. The area of that rectangle was the parabola all along. Now let's take a look at our parabola over here. Let's take a look at our parabola over here. All right. The y value of this parabola is the area of x squared minus 121. Okay, that y is equal to x squared minus 121. When x is between 11 and negative 11, it will have a negative area. I'm cutting a piece bigger than x squared out of the parabola. No such thing as negative areas. So really, it's only this part of the parabola that goes off, and it grows very quickly as x gets bigger. As x gets a little bit bigger than 11, like if x is 12, you found the area of a 12 by 12 square with an 11 by 11 square cut out. Jimmy? Yeah, sure, go ahead. That's fine. Yeah. So that's connect your parabola to your ideas of slope, to your knowledge now of factoring, to a graphical picture. The more of these connections you can understand and like fit in your mind at once, the more this idea will be very durable in your mind. Okay, so now we have perfect square trinomials. These are just special cases of other trinomials. They're going to have factors that are the same. Watch this. And we just want to look at these to see them. They're not hard. Okay, y is equal to, they're not hard if you know how to trinomial factor. I'm not saying trinomial factoring is easy. I'm saying if you can trinomial factor, these are no added degree of difficulty. If trinomial factoring is difficult for you, I get it. I feel your pain. Now here, y is equal to, I want numbers that multiply to 25 and add to negative 10. What are those numbers?
Oh, 5 and 5.
What flavors of 5?
Negative 5.
X with negative 5 and x minus 5. Cool, eh? Yeah. So now, notice that these factors are the same.
Yes.
Yeah. So this could be written as y equals x minus 5 squared. What form is this parabola now in? Box to cube, it is a square, but it's another form. I'll remind you, this is a variation of y is equal to x minus h squared plus k.
Oh, vertex.
This is in vertex form now.
Oh.
Perfect square trinomials. This is factored form, but it's also vertex form. Okay? So this is vertex form. This is an idea that we're going to be using next unit. Perfect square trinomials are a stepping stone on the way to vertex form. And we're going to learn how to turn any trinomial into a perfect square trinomial to then put it in vertex form. We get a little baggage along the way, and that becomes our k. That rhymed. Thrilled. Okay. So these are perfect square trinomials. They can be written that way. La-di-da-di-da. Get some practice. Okay. So here, if I have y is equal to a plus b squared, then that would expand this way. You're going to see them as a squared plus 2ab plus b squared. Okay, that's how they're going to look. You don't need to be able to recognize them at this point. You just need to be able to factor them. They factor like normal trinomials, But when you get the same factor, like a minus b, then put it together, a minus b squared is nice. It's style points. So it says example, factor this one. Here, this is 2ab, this is b squared. So this is going to be y is equal to two numbers multiplied to 16, add to 8. 4 and 4. X plus 4 squared. Done. Okay. 4 times 4 is 16. 4 times x is 4x. 4 times x is now 8x. X times x is x squared. That's my FOIL rule. It's going a little faster. Going a little slower now. X plus 4 times x plus 4. FOIL that guy. You get x squared plus 4x plus 4x. If you're going to write it out, Mr. Jennings, take the time to write it nicely. 4x plus 4x plus 16 is that. Okay. This is perfect square trinomial. Oh, well, I have a clue here. My clue to factor this one is that I've been told that this is a perfect square trinomial. This is 2x squared minus 5 squared. Sorry, 2x minus 5 squared. So how do I do that? Let's use our Brian McLogan patented 4 times 25 is 100. I'm looking for numbers that multiply to 100 and add to negative 20. Multiply to 100 and add to negative 20. Negative 10 and negative 10. Okay, so this would be y is equal to 4x squared minus 10x plus 25. Okay, 4x squared minus 10x. Factor that. Out comes a 2x. 2x times 2x minus 5. And then factor this. A 5 comes out. Actually, a negative 5 can come out. Negative 5 multiplied by 2x minus 5 is this part. And now these can factor. Notice 2x minus 5 in the brackets and 2x minus 5 outside of the brackets. So that when I factor this, again, 2x minus 5 multiplied by 2x minus 5. When I have the same factor come out when I've done my trinomial factoring, I can write it as a 2x minus, I can write it as that factor squared. That's now vertex. That's not quite vertex form because this 2 is inside. It would need to be outside to be in vertex form. And it would become a 4. It would be this number here. So this isn't exactly vertex form. Can't read the vertex from that. The vertex is actually at 5 over 2, not at negative 5. Not at positive 5, sorry. It's at 5 over 2. Okay, so these are how to factor perfect square trinomials and how to factor difference of squares. I was especially excited about the perfect square trinomials and the differences of squares. Differences of squares have their vertex along the y-axis. Perfect square trinomials will have their vertex along the x-axis. And I'll show you why. The perfect square trinomials are going to factor into things that look like y is equal to x plus 4 squared. Notice there's no k, so that means k is 0. That means the value of the y of the vertex is 0. Okay? And it's at x is minus 4 is where this vertex is. Okay, let's graph this in Desmos. X squared minus plus 8x plus 16. We have x squared plus 8x plus 16. There's our perfect square trinomial with its vertex at negative 4. If I flip the sign on this negative x, sorry, this positive 8, it's just going to flip over there. It's now going to factor at positive 4. Because it would now be x minus 4 squared to make that trinomial. See? And I can create more of these perfect square trinomials. Y is equal to x squared plus 4x plus 4. That's also a perfect square trinomial. It's x plus 2 squared. Let's do x plus 3 squared. y equals x squared plus 6x plus 9. There, that's at 3. Okay. Because this would be x minus x plus 3 squared. And you can build more. They will always have their vertex along the x-axis. If you want a parabola with vertex along the y-axis, then do a difference of squares. Like y is equal to x squared minus 9. There. Has its vertex at -9, and it's a perfect square. It also shares roots -3 and +3.
Oh, I remember.
Okay. X squared minus 9. Difference of squares. Minus 16 now has roots at -4 and 4. Minus 100, roots at 10 and 10. 144, 12 and 12. 69, 13 and 13, 169. 13, difference of squares. Okay. Okay, that's a longer lesson than I thought.